Okay, so this one's a little bit different. I've got both kinds of problems on the test. The good news is that it's easy to find the force that the engines exert. So force times time is mass change in velocity, right? So this is pretty simple. When they give you the burn rate, you just basically multiply that by the exhaust velocity. But let's do what we're supposed to do. So force times, remember what you do here is you say it's 1.54 kilograms in 1 second. So I'm going to say that the time is 1 second, right? And that in that time, 1.54. These always have to go together, right? Kilograms is burned, right? And then our exhaust velocity is 821. All right, so 1.54 times 821. Don't forget to divide that by 1. Okay, it's 1264.34. Did I do that right? I think I did. All right. So that's the force that we're going to use, okay? The next thing we're going to do is we're going to figure out the initial and final mass, and that's kind of hard on this problem, but not really. Okay, so the initial initial mass is 43.0 kilograms. That's easy, right? But then it's like, uh-oh, how much fuel does it burn? It doesn't tell you that, right? But it tells you that it burns 1.54 kilograms every second for 13.7 seconds. So the fuel is going to be what? 1.54 kilograms per second times 13.7 seconds, right? So the seconds will cancel, we'll get kilograms, right? Does that make sense? We really don't have a formula for that. 21, so there's 21.098 kilograms of fuel. So the final fuel is just 43 minus that 21.098. So 43 minus that is 21.902. Yeah? So this is our final mass. This is our initial mass. Now, it's worth, at this point, let's just double check that. So 43 minus 1.54 times 13.7. Sure enough, it's 21.902. Okay, so now we're set. We can figure out our F equals ma, right? So in the first case, we've got a 43 kilogram rocket. Right. The force upward is this 1264.34. The force downward up, we haven't figured that out yet. So force of gravity is 43 times 9.81. $421.83. Okay, so now we're set. We're going to go 1264.34 minus 421.83 equals 43A. All right, hold on. Okay, so minus that 421 divided by 43. And I'm getting 19.59, so 19.6. That's solidly 2 G's, right? There are actually people that do this, like they make big rockets like this, liquid fuel rockets, and launch them in the Mojave Desert. I know this because one of them was my student years ago. Okay, so now we've got this rocket that is 21.902 kilograms, right? There's still going to be 1264.34 newtons of force upward on it, right? The downward force, so that's newtons, right? The downward force is, we got to figure that out, force of gravity is 21.902 times 9.81 times 9.81 is 214.85. 85862. Okay, so 214.85, 862, and then we can set this up, right? So 1264.34 minus 214.8, I'll just say 86 for fun, is equal to 21.902 times A. All right, okay. Let's see, let's find that guy. There it is, 1264 minus the 214 number is that divided by 21. Oh my gosh, I got that. I'm going to cry. I got the right answer. Okay, A is equal to, the problem with these is you don't know if you got the right answer to the very end, right? 40, I guess that's always true, right? 47.9 meters per second squared. Yay. Yeah, again, so it's the same recipe, right? Before you begin, you have to find the initial and final mass. You got to find the thrust. Remember that this has to be the mass of fuel, and that has to be the time in which that fuel was burned. So in this case, it was 1.54 kilograms in 1 second, okay?